Hello and welcome to this lesson on databases in Android. In this lesson, we will cover the usage of SQLite databases in Android applications. SQLite is a relational database management system created in 2000 by D. Richard Hipp. A relational database management system is a database management system that is based on the relational model where all data is represented in ordered lists of elements grouped into relations. SQLite is also an embedded database system, which is a database system which is tightly integrated with an application software that requires access to the stored data, such that the database system is hidden from the application's end user and requires little or no ongoing maintenance. The SQLite database management system implements most of the SQL 92 standard for SQL, but lacks some features like full support for triggers and writing to views. All of the code and documentation in SQLite has been dedicated to the public domain by the authors. SQLite Open Helper is a helper class for database creation and version management. It is an abstract class, so when developing, we must create a subclass that implements several of the abstract methods of this class. The onCreate method is called when the database is created for the first time. This is where the creation of tables and the initial population of the tables should happen. The upgrade method is called when the database needs to be upgraded. This implementation should use this method to drop tables, add tables, or do anything else that is needed to alter the tables to upgrade to the new schema version. If you add new columns, you can use alter table to insert them into a live table. If you rename or remove columns, you can use alter table to rename the old table. Then create the new table, and then populate the new table with the contents of the old table. In addition, there are some optional methods that can be overridden. For instance, onOpen, which is called when the database has been opened. The implementation should check is read-only before updating the database. This method is called only after the database connection has been configured and after the database schema has been created, upgraded, or downgraded as necessary. Once the custom SQLite Open Helper derivation has been implemented, the database can be opened for reading by calling the method getReadableDatabase, which will create and/or open a database for read-only purposes. If a writable database is required, then the method getWritableDatabase can be called upon an instance of the custom SQLite Open Helper derivation. Both of these calls will return an SQLite database object. The SQLite database allows for direct interaction with a given database, including methods for creating, deleting, and executing SQL commands on a given dataset. Commands that require changing rows of the database will require write access to the database. Transactions in SQLite are a set of operations performed on a given database. This set of operations are processed in a logical order. Their purpose is to provide reliable operations that allow correct recovery from failures. When a transaction is ended, all of the work done in that transaction and all of the nested transactions will either be committed or rolled back. The changes will be rolled back if any transaction is ended without being marked, as otherwise they will be committed. The SQLite database class also includes convenience methods for common operations. Some of these methods allow for separating the where arguments from the where clause itself. In this case, the where clause could be a string like name equals question mark and ID equals question mark. This can be used in combination with where arguments like the string array of the string John and string 0. Then when these parameters are used in combination, they will produce the where clause of where name equals John and ID equals 0. Some of these convenience methods include delete a row or rows by calling the delete method, which deletes a row or rows in the database. The method receives the table name as a string, the where clause for applying deletion as a string, and the where arguments for injecting arguments into the question mark placeholders in the where clause as a string array. Update a row or rows by calling the update method, which updates the corresponding row or rows in the database. The method receives the table name as a string, the update values as a map of column names and values, the where clause for applying updates as a string, and the where arguments for injecting arguments into the question mark placeholders in the where clause as a string array. And insert a row into a given database by calling the insert method. The insert method receives the table name as a string, a null column hack string which if not null provides the name of a nullable column name to explicitly insert a null into, and values as a map of column names and values. After performing certain queries on our database, we may require to access the results. The results from certain SQL database calls like query, raw query, query with factory, raw query with factory, will be passed back in the form of a cursor object. The cursor object allows read-write access to results from database queries. It is important to note that the implementations of cursors and cursor derivations may not necessarily be synchronized, so the code utilizing a cursor should perform synchronization if it is accessed over multiple threads. The cursor object allows us to easily iterate over the rows of the result by using methods like getCount, which returns the number of rows in the cursor, moveToNext, which moves the cursor to the next row, moveToFirst, which moves the cursor to the first row, and moveToLast, which moves the cursor to the last row. These calls will return a Boolean value, which will be true if the move succeeded or false if the move did not succeed. Once we have the cursor pointing to a specific row of interest, we can grab values from that specific row by calling methods like getString, which will return the value of the string for a given column index, and getDouble, which will return the value of a double for a given column index. Calling a getString on a double value can cause an error or throw an exception. In order to verify we have the right type, we can use the getType method on a given column index, which will return the data type of that column. In this demo application showcasing the usage of SQLite in Android, our goal is to create a simple app for saving contacts with numbers to a database. Let's take a look at our UI. The layout for our main activity has two edit text fields, one for the name and one for the phone number, and two buttons, one to save the contact to the database and one to find a number for a contact in our database. Now let's jump over to our main activity and see how these features are accomplished. In our main activity, we obtain a reference to our two edit texts, and we create an instance of a DB helper, which we'll look at in a moment. In the callback for our two buttons, we determine which button was pressed by the ID of the view. If the Save button is pressed, we call the method addNameNumber in our DB helper, and send it the text from our name edit text, and from our number edit text. If the Find button is pressed, we query our DB helper by passing it the text from our name edit text to the Find Number from Name method. And if the name exists in our database, the DB helper will return a string of that number, which will be displayed in a toast. In case the number is not found, then the DB helper will return a null string, and we will post a toast saying there is no listing for that name. Now let's take a look at our DB helper class. Please note that although we are doing some database operations in this sample on the main UI thread, in normal cases, database operations should not be performed on the main UI thread. We will cover more about threading in future lessons. In our DB helper class, which extends the SQLite Open helper, we implement our database API. We have declared in our constants for the database version, the name of our table that we will create, the column name for our contact name column, and the column name for our phone number column, a string for an SQL statement to create our table, and a string for an SQL selection statement to find numbers in our database. In our constructor and our onCreate, we establish what is needed in order to create our database and the table for storing our contact information. We have no information in our onUpgrade callback because this is the first version of our database, but this is where code will go when changes or alterations are needed for upgrades to a database. In the addNameNumber method, we open our database for writing and creating content values to add a name and number to our database. Then we call the insert convenience function and pass it the content values that include the name and number we have just received from our activity. In our find number from name method, we get a readable version of the database. In this case, the database will not be writable because we only need to find a query according to our parameters. We use our selection where clause along with the selected arguments of name that is passed from our activity. In case more than one result is found, we go to the first result and return the string value for that column. Then we return the string or null if the name is not found. Now let's run the application on our emulator and see how this application plays out. If we type a name into the name field, and then we click the Find button, we'll notice that Toast is displayed saying there's no listing, because we've yet to add any name-number combinations to our database. However, if we click in the number text field, and now we add a number for the name, and then we click the Save button to save this name and number combination to our database. When we click the Find button, it will find this contact in our database. Thank you for joining us in this lesson on databases in Android. Join us in our next video where we will cover the lab exercise for this section.